Hello and welcome to Expanding Your Horizons' first ever Meet a Scientist series. This is where we get to sit down with a real scientist and ask the questions you've submitted either on our website or at our webinar from last spring. My name is Jenna, and first I would like to introduce our special guest, Dr. Lilli Morris. Lilli got her bachelor's at Williams College and then her PhD at Cornell in chemistry. She is an assistant professor at the Department of Chemistry at the College of Wooster. Lilli, would you like to just say a few things about yourself?
Hi, everyone. Jenna covered it pretty well. That's my academic background. I'm originally from North Carolina, and then I bounced around the Northeast a bunch for school, and now I'm in the Midwest, continuing my tour of the country. But UH has a special spot in my heart, so I'm really happy to be here.
Cool. Well, can you tell us a little about what you do and like what got you excited about STEM and really when you knew you wanted to pursue this field?
Absolutely. So I was excited about STEM when I was little, and what I wanted to do with it changed a bunch and perhaps should have changed more. So little kid Lilli wanted to be a marine biologist, despite the fact that I lived nowhere near the ocean, but I had decided I was going to study all things ocean. And then I got maybe a little more realistic in things I saw, and I was like, I'll be a doctor. I want to help people, and I like science, so I'll be a doctor. So I went through the doctor phase, and the doctor phase lasted solidly through my junior year of college. So I completed the entire pre-med track. And then it was really my professors at Williams who were awesome and super kind, because chemistry was really hard and I struggled, and I spent a lot of time in their offices. And they were always really kind to me. And I was tutoring in our Math and Science Resource Center at the time, so I'd started to get a taste for teaching and how fun that was. And I was doing research at the time with one of my professors. I was like, hey, this research and teaching thing, that's pretty fun. And doesn't seem maybe as stressful on my day-to-day life as being a doctor would be. That perhaps was a little wrong. But the balance of the teaching part was really awesome. And so I decided that if I wanted to help people, and I liked science, that teaching was another way I could do that. So I went to grad school, studied sustainable plastics, and now I'm teaching, which is really fun. My day-to-day is a huge mix of things, and I don't think I understood that even when I was a student. I currently have 4 seniors who are writing independent studies with me. So I have 4 research students who are all working on independent research projects. So I help them think about their research and what directions to go in next, and how do we answer that question? What question should you ask? Did you run that control experiment? A lot of that. And then in any given semester, I'm teaching 2 classes and a lab on average. As someone who did catalysis, I really kind of sit at an interface between a lot of chemistries, which is really fun as a field, but also means that I can teach a lot of different classes. So I've taught organic and gen chem, and then inorganic. I'm the sole inorganic chemist in the department, which means I'm the one that works with the metals and gets to teach people about the metals. So I teach that every spring, which is really fun because there's lots of pretty colors in that lab. So we make rainbows all the time. So that's a lot of what I do in my day-to-days. Work with my research students and then do teaching and plan for teaching. But what I don't think I understood is that professors are the ones kind of running things behind the scenes, at least at a small liberal arts college. So you work on committees. So I was on a committee this semester that decided how extra research funding could go to seniors with really exceptional projects. So I got to read lots of proposals from seniors doing super cool things across the college, super inspired by those seniors. They're like, I'm doing this awesome thing. And I was like, I didn't even know we could study that. Cool. So that was a lot of fun. And then doing kind of community stuff with the department and figuring out, how do we run this, or how do we improve our department? How do we make things more accessible to a wider variety of students? So that's kind of what my day-to-day looks like and how I got here.
Cool. You said something really interesting that sparked a question in my mind. You said chemistry is really hard and your professors are really great helping you with that. Do you have any advice to our viewers, listeners, on how to persevere through the struggles of science for maybe people who are really interested in STEM, but it is a struggle for them?
I think the first thing is to find people that will acknowledge that STEM is hard. I think it's really easy as you get distanced from a particular class, let's say Gen Chem, right? By the time I taught Gen Chem last year, I had sat through Gen Chem and TA'd Gen Chem, and I had seen Gen Chem a lot of times. And it's easy to be like, oh, well, obviously, this thing is true. And it's not obvious. It's really hard the first time you see it. So finding people that will acknowledge that it's hard is a positive, but also finding your people, and whether or not that's a professor that you trust or a teacher that you trust who will kind of help push you and know when to say, try a little harder here, be like, that just really is unfortunate, and know when to empathize. But also I think finding a group of people that you can work with, and we called it Chem Fam in Gen Chem. I got to college and I got really overwhelmed. I had great high school chemistry teachers who were great role models, but I took like Gen Chem 1 and Gen Chem 2 in one semester. And little freshman Lilli found that really overwhelming because you're talking about like quantum mechanics on week 2. And I was like, I'm not qualified for this. And so having this other group of students that I was talking to and working with and doing problem sets with, and having them acknowledge like, this is really hard. I was like, oh, it's not just me. So I think finding people that will be honest with you and say, help you when you need help, but also acknowledge that things are hard, I think is really important. So community, I think, is at the heart of that, finding your community.
Cool. Yeah, I think that's a really important thing to just bring up, because there's probably a misconception that everyone in STEM just finds it easy.
I think that's a huge misconception. We talk about that. Usually when I give back a first exam, and we can have all sorts of opinions on exams. They're a singular point in time and don't really measure all of student learning. But I have a conversation about the fact that I did so poorly on an exam in bio at one point in college that my dad bought me a book on like coping with failure, because I was a very type A person who had like succeeded really hard in high school. And then I got to college and was like, oh boy, like, need to adjust some standards here. But like, that's fine. I still turned out, I'm still a scientist, but it was hard.
Yeah, exactly. Now let's like rewind a little bit. What kind of things inspire the work that you do with your students?
Absolutely. So a lot of it is inspired kind of by work I did either with professors in undergraduate or my graduate work. I was really lucky, and I worked with Professor Coates at Cornell, and he studies sustainable plastics. Right, so we can all acknowledge that plastics are ubiquitous. They're everywhere. And so plastics are great in so many ways, right? Like if you think of the PPE we need right now in the pandemic, like we kind of need single-use plastics. They serve a great function. And there's a lot of plastics that are super strong. If you think of fishing lines, like they have all these great properties. But we also have the Great Pacific Garbage Patch. And there's this like dark side of they're hard to recycle sometimes, and recycling isn't perfect, and they escape in the environment. And when I decided that I wanted to go into chemistry back in undergrad, I wanted that chemistry to felt like it did something good for the world. And research in general does, but for me, sustainable plastics felt very immediate in its fix the worldness. And so I really like working with sustainable plastics. That's what I continue to do with my students. And so currently we're focusing on, can we take things that are typically petroleum based, so where the feedstock is not great environmentally, and transition into plant-based feedstock? And if so, how much do we compromise the properties of those plastics? Is it something we're like, yeah, this is mostly still fine, and all of those benefits totally outweigh all of the, slightly less awesome properties? Or is it something that we're like, nope. We haven't finished answering that question yet. But that's mostly what we're doing, and got into it because I wanted to feel like we were making a difference. So we're working on making sustainable diapers right now in my lab, actually.
That's really cool. And in a way, you're still kind of like a marine biologist helping the ocean.
Right? I'm going to help those fish in the ocean, just in a very different way.
So you already sort of spoke to what working in academia is like. Pardon me. Do you think there's like a really important skill that you needed or you do need to be successful in this job? And if there is, how have you developed it?
I think there are several. Persistence is one. I mean, we already talked about the fact that I think science is hard, and you just keep going. And applying for academia is hard, and you just keep going. And so just continuing to believe that like the path you're on is the right path is super important. And a boatload of empathy, because I think, especially right now, let's say, right, like for as many bad days as I had while I was teaching this fall, my students were also having a lot of bad days. So continuing to approach your students and yourself and your colleagues with a boatload of empathy, I think is perhaps one of the best things you can do. That's something you can practice when you're little and younger and developing as a person and a scientist. And I think it's such an important skill, regardless of what kind of science you go into. and one I think I underestimated that I'm super thankful to my parents. So neither of my parents are scientists. And my dad was in sales for a long time. I know does financial planning for people. And so he used to take me along to all these networking events and just kind of be like, good luck, Lily, go meet some people when I was in high school. And at the time I was like, what is wrong with you? Turns out that's an important skill. Talking to strangers is a really good skill in academia because, right, I'm the only inorganic chemist at Wooster, and I'm the only polymer chemist right now at Wooster. And I love my colleagues. They're great. They do all sorts of cool science. But if I have an inorganic specific question, I need to talk to an inorganic person at another institution, which means I need to have befriended an inorganic chemist at another institution. So I think that ability to make friends and talk to people and view everyone as like a, hey, we could be buddies, maybe research buddies, maybe teaching buddies, maybe just buddies within academia is super important, and something that I think, especially within grad school, something we could be working on better. Something I definitely didn't practice enough of while I was a graduate student.
Little different, sort of similar. I worked for a few years before going to grad school, so I get the whole networking thing is very important and definitely an important skill to have is just, putting yourself out there, making science friends.
Exactly. So many science friends.
And we did talk about this a little bit, but do you have any more advice for our younger scientists that are out there? Like, is there something you wish you had known when you were in 8th grade?
I think keep exploring would be my best advice. I think I'm very happy with all the choices I made, right? Like I made right choices at the time for me, but there are so many different ways you can do science. And even though I grew up around a lot of scientists, I didn't necessarily realize the number of different ways you could do science or even chemistry. That took me until graduate school to realize a bunch of the different chemistry career paths, let alone scientific career paths. So looking into, okay, I could do science by being a science communicator, or I could do science by developing science curricula, or being a cosmetic chemist. We were just talking about this in organic chemistry. So these are all very organic chemistry specific, but all of the different career paths that could take, that being a scientist in no way looks like one thing. It looks like a whole lot of things. And I definitely didn't realize that. And I think that would be the thing I wish I had realized and hope that younger students get to realize, is that there's a lot of different ways to do science.
I mean, I know you're speaking to me because when I was little, like the two things I could think of was you could be a doctor or you could be a veterinarian. And like, those were the two science careers I could really think of. For me, at least, like I really didn't know what my other options were. So I went into undergrad, like, I'm going to be pre-vet or pre-med. And then like halfway through my first year, I was like, nope, not going to do this. I don't know what I'm going to do, but it's going to be science. So yeah.
That's like half of people in grad school. Like I was pre-med and then.
Yeah. It's like, nope, not for me. Don't like this. But yeah, I think that's a huge, like you get tunnel vision almost as a kid. Not that there's anything wrong with that if you like what you like, but don't get blinded.
Like being a doctor is great. Being a veterinarian is great. There's all these other great things.
Yeah. Keep your eyes open, basically.
Exactly.
So when did you first think of yourself as a real scientist? Was there like a specific aha moment, or was it more of this gradual feeling?
I think for the most part, it was gradual, right? And I mean, I'll talk to my students about the fact that if you're taking a science class, you're a scientist. But I was really lucky, and I went to a conference in undergrad with my advisor at the time. And it was the national conference. It was the American Chemical Society National Conference. And I walked in, and it's the New Orleans Convention Center. It's huge, right? Filled with thousands of chemists. And I was giving a poster at the nighttime poster session for like the special poster, right? We might have won this like undergraduate award thing. And I was like, oh my God, I'm a real chemist. Like people are asking me legitimate research questions. And all of a sudden I was like, oh, guess that's me now. And it was so cool. Like I remember calling my mom when I got home, and she was like, how was the conference? And I was like, Mom, there was so much science there. And it was so cool. So I think it kind of like snuck up on me, but that was the aha moment of like, at some point I became a scientist, and I guess I'm a scientist now.
That is a cool moment where it's not like you're getting tested on knowledge or being asked questions about your research. It's like a really fun, cool moment.
Yeah, and just being surrounded again, because I mean, I love small schools. I chose a small school for a reason. But you see, right, your few professors doing their few types of research, and I got to this big conference, and there were so many types of chemistry research, and kind of getting back to that like limiting idea where I was like, okay, well, I guess there's this kind of catalysis, and there's this kind of, this, that, and the other that I was seeing at school, and then I got there, and I was like, oh, there's like 20 other fields of chemistry that I even realized. Like, oh boy.
That's awesome. Okay, well, this is our last question. And so we're going to end on like a fun, silly question. What's the goofiest thing you've ever done in your science career?
Okay, I'm going to give two. I was thinking about this. So one thing I underestimated about chemistry grad school was perhaps how much fix-it you have to do in lab. So my group job for a while with one of the people I think you're interviewing later, Dr. Erin Hubble, we had to take care of our glove box, which is just a big box filled with nitrogen that has like gloves sticking out. And the thing about glove boxes is they're not exactly like great for trying to get at these weird angles where you're trying to fix things when something goes wrong. So I remember one time where Erin and I were trying to fix the glove box that we were in charge of. And she's like behind it in this way. And I'm like trying to hand something to her while like climbing under the other way. And that was just, it was a constant stream of us like crawling on our backs trying to do things in science. So that was goofy thing number one, because you had to laugh at the ridiculousness. Goofy in my day-to-day life, molecules in chemistry move a lot, and I'm someone who likes to personify molecules while I teach, because I think it gives a lot of intuition, right? Like it's really great for that. So my students can attest to the fact that I usually try and like explain the molecules as if it's this person that's existing, which sometimes means that I'm acting out that person while it's existing. So last year we were talking about molecules that had like lots of electron shells, atoms that did. And so we were talking about it as if it was like a kindergartner that had a snowsuit on, right? I was like waddling around like I had a snowsuit on. So that's my goofiness in my current day-to-day life, is acting out molecules.
That's great. I will say every chem TA I've ever had has been so cool under pressure, because I've never had like a chem lab in high school, graduate or undergraduate school that's gone smoothly. Something always goes wrong, and it's always just like, okay, yeah, whatever. We'll deal with it. Oh, that's leaking. Not, yeah, no, yeah, you're fine. Don't worry about it. just keep going. Just so calm under pressure.
I feel like that's the sign of like a well-tested TA. Internally, we're screaming a little. But,
just like, not again.
Not even that, just like the minor panic. You're like, okay, there's no fires. Okay, we're good. Like we can move on.
Well, thank you, Lilli, for taking the time to answer our questions. It was really great. I really appreciated your insight and talking about persevering through the difficulties of STEM and kind of talking about that misconception. I thought that was really great. And I hope our listeners enjoyed it as well. So if you would like to know more about EYH, please go to our website at eyh.cornell.edu. You will find a link to the website in the description on our YouTube channel. You can submit questions on our website and explore more about our previous programming as well. So thank you for listening, and make sure to subscribe and get notified for more content. Bye-bye.